Hello, I welcome you all. The problem reads a hockey puck is traveling to the left with a velocity of 10 meters per second when it is struck by a hockey stick and given a velocity of 20 meters per second as shown. Determine the magnitude of the net impulse exerted by the hockey stick on the puck. The puck has a mass of 0.2 kgs. This problem is coming from the Engineering Mechanics and Dynamics, 13th edition by R.C. Hibbeler. So we are using the concept of impulse, linear impulse and linear momentum, and let's look at what is happening here. So this puck is initially moving at a velocity of 10 meters per second coming from this direction, right? And then this hockey stick, applies a force on it. So the moment this is in contact here, the moment the stick and the puck are in contact, the stick transfers a force over a certain period of time, which we are calling impulse, and this impulse changes the momentum of the puck. Alright, and it moves in the direction of the impulse. Since impulse and momentum are vector quantities, they have both direction and magnitude. Right, and force, which is impulse times delta t, is equal to m times change of velocity. Okay, so let's just draw the free body diagram here of the forces. We see what is happening. So let's draw another component in this direction like this. So let's call this one our we call this one, let me use another color. Right, so from here, there we go, and then we have another component, there we go, like so. So let's call this one here is y, we call this one as x. Right, so let me just name the forces directly there. That's x, of course, and y. So let me have another one. Let me say okay, it's fine. So this axis here is x, this axis here is x, and this is y. Okay, so this, let's name this as our v2 sine 40, and this one is our v2 cos 40. The other one is in the x-axis. So let's write down the vector expression for velocity. So our velocity here, is going to be equal to v final or v2 minus v1. Okay, alright, so this one is a change in velocity, and this one is just going to be equal to our v2, let's write it, the x component will have v2 there, cos 40i, okay, positive, and we do have a v2 sine 40j. Okay, then we have a minus like so, and this one is v1, there's only one component, and this minus 10, no, we'll just say minus v1, okay, like so. Alright, minus v1 in the I direction, and it's negative, and our change here is just going to be equal to let's replace this with numbers. V2 is 20, so this is 20 cos 40. Okay, and then this one will say plus 10, say 10, this is 10, and then all of these are i's, and then we'll say plus we're going to say plus, where is v2? V2 is 20 sine 40 j. Okay, so this is what we have at the moment. This is the difference. Then let's write down the equation. So we have F, which is the force, then force by delta T is equal to M delta V. Okay, alright, but this is what we want. So we'll say let I be equal to F delta T. Okay, therefore our I, which is a vector, this impulse is just going to be equal to M delta V, and our M is equal to 0.2, and then later on we have all these components, 20 cos 40 plus 10. Okay, plus 10 I. We can remove this for now. Okay, remove this I, and then we have okay, need this one there. Then we have plus 20 sine 40 j. Okay, then this gives us, and this is just going to be equal to, if we worked out this, we have a 0.2 times, first is 20 cos 40 plus 10 by 0.2, so this we get a 5.0642 I, then will be like plus 20 sine 40 by 0.2, so this we have a 2.5712 J. Okay, therefore the magnitude of this is just going to be equal to 5.0442 squared plus 2.5712 squared, and everything under the square root. Right, and then finally we have I, just I is equal to, let's work out this, I, which is equal to the magnitude, like so, and this is equal to, that's 5.0642 squared plus 2.5712 squared, and square root of that. This gives us a 5.68 Newton second. Okay, so it's Newton second. Alright, so found the momentum, the net, we found the magnitude. Let's find the angle. So for the angle, we can draw this. So this is both positive. We have something like that. We have something like that. And then we have the magnitude towards this direction, like so. Okay. So let's write down. So this one is Ix, this is Iy, and this is I. Alright, and then we have this angle here that we are interested in. So theta is just going to be equal to tan inverse of Iy divided by Ix. Okay, where Iy is equal to 2.5712 and Ix is equal to 5.0642. Therefore, theta is just going to be equal to 2.5712 divided by 5.0642, and then tan inverse of that, we have an angle of 26.92 degrees, and this angle is like so. Okay, I think this is about it. We found the magnitude of our impulse in Newton meter. And we've also found the angle. Okay, so I think this is about it, and I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.